Hello students, welcome to second lecture of D and F block elements competitive. So today we are going to discuss about iron and its compounds. So first of all, ores of iron. Now some of the informations are related to some other units as well, because eventually all of these units are related to each other. So there is a possibility that some points are common between two different units. So this point can also be included in metal abstraction unit, general principle of metal abstraction. So this information is already mentioned there, but let's quickly observe. So ores of iron: hematite, magnetite, limonite, iron pyrite and copper pyrite. So these are the examples of ores of iron. That means when we dug into the earth crust, you will find these type of different compositions of the iron metals. Now extraction method. So abstraction method is already discussed in that unit as well. So first of all, extraction has a steps, different steps. So first thing, roasting, then smelting. Now what is abstraction? When we dug into the earth, we get many different type of impurities along with our iron compounds or metal compounds. As for example, dirt, some other metal compounds, different type of form of same metals, and stones, etc., silica impurities. So in abstraction method, we are going to increase the percentage of our main metal compound. So cast iron is extracted from its oxide by reduction with the carbon and carbon monoxide in blast furnace to give pig iron. So simple Fe2O3 H3H2O gives Fe2O3 plus 3H2O on heating. That means water vapors will be removed. Then Fe2CO3 will convert into FeO and carbon dioxide will be released, and FeO will convert in Fe2O3. Then in smelting process, reduction of roasted ore of the ferric oxide carried out in a blast furnace, and we have few different steps. So first, reduction of ferric oxide is done by carbon and carbon monoxide. That means CO2 gives CO. Here two carbons and one oxygen gives 2 CO molecule. Now this CO will react with Fe2CO3 and it will convert into carbon dioxide, and we will get our reduced Fe metal in metallic state first time during this process. It is reversible and exothermic reaction, hence according to Le Chatelier's principle, more iron will be produced in the furnace at lower temperature. So Fe2O3 plus CO, it gives FeO and CO2, which is not reversible step, but this FeO plus carbon will convert into Fe and CO. So either carbon or carbon monoxide, we can use both of them to reduce FeO. So here second product is carbon monoxide, and obviously it will be in gaseous state. So removal of carbon monoxide is easy. We just have to let it go. So by removal of one of the product, we can increase the overall percentage of reaction. According to Le Chatelier's principle, if concentration of product decreases, then reaction will move in forward direction. That means if we remove the CO from the reaction, we are actually decreasing the concentration of product, and more forward reaction can be obtained. Now gas living at the top of the furnace contains up to 28% CO and are burnt in coal power stove and preheat the air for blast. That means we can use this produced carbon monoxide during the reduction process of FeO to heat our air, so that our overall consumption of energy can be reduced. Now we have different type of iron compounds present. So the three commercial varieties of iron differ in their carbon content. So cast iron or pig iron, which has 2.5 to 4% of impurity of carbon, but still this 2.5 and 4% impurity is considered most impure form of iron. Second is wrought iron or malleable iron, which has 0.12 to 0.25% of impurities, which is considered purest iron, which can be used commercially. Third is steel. Steel is not actually a separate iron metal, but it is alloy of iron. That means it is mixed metal. So it is most important form of iron and finds extensive application. Its carbon content impurities is midway between the cast iron and wrought iron. It contains 0.2 to 1.5% of carbon. Steel containing 2.2 to zero point 0.5 of carbon are known as mild steel, while those containing zero point 0.5 to 1.5 are known as hard steel. Steel is generally manufactured from the cast iron by three processes, that is Bessemer process, which involves the use of large pear-shaped furnace or vessel called Bessemer converter. LD process, and third is open hearth process. Spiegelization, which is alloy of FeMn and carbon, is added during the manufacturing of steel. Now next is heat treatment of steel. The heat treatment of steel may be defined as the process of carefully heating the steel to high temperatures followed by cooling to the room temperature under controlled condition. The heat treatment of steel is done for the following two purposes. First, development of certain special properties like hardness, strength, ductility, etc. without changing the chemical composition. And second, removal of some undesirable properties or gases like entrapped gases, internal stresses or strains, and various method of heat treatments are involved in it. Some of them are mentioned here. Annealing is a process of heating steel to redness followed by slow cooling. Redness, that means we have to heat it so hard that it becomes glowing red. Quenching or hardening. It is the process of heating steel to redness followed by sudden cooling by plugging the red hot steel into the water or oil. So sudden cooling, that means it can sometimes crack up the steel. So we have to be careful. Now tempering, it is the process of heating the hardened or quenched steel to temperature much below the redness 473 to 623 followed by slow cooling. Next is case hardening. It is the process of giving thin coating of the hardened steel to wrought iron or to a strong flexible mild steel by heating it in contact with charcoal followed by quenching in oil. Nitriding. So it is the process of heating steel above 700 degrees Celsius in an atmosphere of ammonia. This process imparts the hard coating of iron nitride on the surface of steel. So it will protect steel from outer attacks of weather or different things. Now property of steel. So properties of steel depend upon the carbon content. With increasing carbon content, hardness of steel increases while ductility decreases. That means flexibility will decrease. With increasing hardness, flexibility or elasticity decreases and our metal or alloy becomes brittle. So low carbon or soft steel contains carbon up to 0.25%. Medium carbon steel or mild steel contains 0.25 to 5%, 0.5, and high carbon or hard steel contains 0.1 to 1.5% carbon. Alloy steel or special steel are alloys of the steel with nickel, chromium, cobalt, wolfram, manganese, and vanadium. Now W is also known as tungsten. Now next we have example of different type of steels with their contents of different elements and with the uses. So as for example stainless steel, which is widely used by our regular utensils or as for example household vessels. So it is resistant to corrosion and it is used for making ornamental pieces, cutlery, etc. Invar has a small coefficient of expansion and it is used for making meter scale, pendulum, rods and watches. Now small coefficient of expansion, that means with changing conditions it changes size with minimal value. That means if we heat that metal or compound, it will expand but very small amount. So that's why we can use it in these type of examples. Meter scales, that means we need accuracy. If it expands or shrinks, that means if it changes size, then we can get false results. Now next is Manganese steel is very hard and resistant to wear, and hence it is used for making rock drills and safes, etc. Next, tungsten steel. It is quite hard and used for making high speed cutting tools. Then we have permalloy. It is strongly magnetized by electric current but loses magnetism when current is cut off. So it is used for making electromagnets, ocean cables, etc. So electromagnets, that means, as mentioned here, when we pass the electricity from the electromagnets, it will produce strong magnetic properties. But when we cut off the power supply, it suddenly becomes non-magnetic compound. Now from next lecture we will discuss about some different properties of iron, which includes many different type of reactions.